Imagine an engine so massive it has 28 cylinders arranged like a giant corncob and 56 spark plugs that need constant attention. This is the Pratt & Whitney R-4360, nicknamed the Corncob. Built in the late 1940s, it powered the largest piston-driven aircraft ever, blending insane engineering with a nightmare of maintenance. Before we explore why this engine is so legendary, let's picture it. The Pratt & Whitney R-4360 is a 28-cylinder radial engine, arranged in 4 rows of 7 cylinders in a spiral. From a distance, it looks like a mechanical cob of corn, gleaming with polished steel and an array of pipes, spark plugs, and cooling fins. This engine was built during the golden era of piston aviation, when engineers were pushing the boundaries of power to lift ever larger aircraft into the sky. The R-4360 powered planes like the B-36 Peacemaker bomber, the Douglas DC-7, and massive cargo planes, giving them the thrust to carry incredible loads over long distances. But as impressive as it looks, the Corncob came with a dark side. Its sheer complexity made maintenance a nightmare. 56 spark plugs alone had to be checked, cleaned, and replaced meticulously before flights. It's a story of engineering brilliance and human endurance, showing just how far we pushed piston technology before the jet age took over. The design genius. What made the R-4360 so remarkable? At its heart is a radial engine design, but unlike typical single-row radials, the R-4360 has 4 rows of 7 cylinders. This staggering arrangement allowed for 28 cylinders to operate in harmony, delivering a jaw-dropping 3,000 horsepower. Why spiral the rows? It's all about airflow and cooling. Air-cooled radial engines rely on airflow over the cylinder fins. Staggering the rows ensures that each cylinder receives adequate cooling during flight, preventing overheating despite the incredible power output. The spiral also gives each cylinder a slight offset, allowing mechanics access and reducing interference between rows. Then there's the ignition system. 56 spark plugs, 2 per cylinder. This redundancy ensured reliable firing under extreme conditions. One spark plug failing could jeopardize performance, so engineers built in a fail-safe for reliability, essential for aircraft carrying troops or cargo over thousands of miles. From an engineering perspective, this was a marvel. Every moving part, every crankshaft, every cylinder had to be synchronized precisely. The engine demonstrates that raw power is nothing without careful planning and execution. A mechanical orchestra where every component must play its part perfectly. 3. Power and performance. The R-4360 was one of the most powerful piston engines ever built, capable of delivering up to 3,500 horsepower depending on the variant. Its torque was immense, giving aircraft incredible lift and speed for the time. For bombers and cargo planes, this meant the ability to carry massive payloads across continents. The engine's design made it more than just powerful. It was reliable at high altitudes. The air-cooled radial design prevented the overheating issues that plagued earlier multi-row engines, and the dual ignition system ensured redundancy. Aircraft powered by the R-4360 could fly longer missions, carry heavier loads, and operate in a variety of conditions. It wasn't just about numbers. Pilots noticed the engine's smooth power delivery, something rare for multi-row radials. The 4 rows of cylinders working together minimized vibration, creating a relatively stable ride for planes that weighed over 150,000 pounds fully loaded. This combination of sheer horsepower, reliability, and performance made the R-4360 a cornerstone of late piston-era aviation, pushing the boundaries of what piston engines could achieve before jets became the standard. 4. Corncob maintenance nightmare. Despite its brilliance, the R-4360 came with a price. Maintenance hell. Imagine having 56 spark plugs per engine and dozens of moving parts exposed to heat, vibration, and pressure. Every flight required careful inspection, lubrication, and adjustment to avoid catastrophic failure. Mechanics described the engine as a mechanical beast. Every cylinder had to fire perfectly, every valve had to move smoothly, and even small errors could ground an aircraft. Changing spark plugs was a time-consuming and physically demanding task, often requiring technicians to climb into tight engine compartments, contort around cylinders, and work in awkward positions. In some cases, entire flight schedules were delayed because the Corncob required meticulous tuning before it could operate safely. Yet despite this, crews praised the engine's reliability once it was properly maintained. The R4360 shows a lesson in engineering trade-offs. Pushing the limits of power comes with complexity. You gain insane performance, but you also demand expertise, patience, and skill from the humans who keep the machine alive. This nightmare maintenance is part of what gives the Corncob its legendary status. A machine of incredible power and beauty that also tested human endurance to the limit. Engineering innovation. The R4360 is more than just a massive radial engine. It's a masterclass in mechanical innovation. Engineers had to solve challenges that no one had faced before. For example, heat management. 4 rows of cylinders generate immense heat. Staggering them in a spiral ensures air cooling reaches each cylinder effectively. Synchronization. 28 pistons, 4 crankshafts, 56 spark plugs. All must operate in perfect timing to avoid destructive vibrations. Compact power. The engine packs enormous horsepower into a space small enough to fit in an aircraft nose without disrupting aerodynamics. This level of precision engineering pushed human ingenuity to its limits. Every component had to be designed for extreme reliability, because unlike cars or ships, engine failure mid-flight could be fatal. The Corncob is proof that mechanical design isn't just about raw power. It's about harmony, balance, and innovation. Even today, engineers study the R4360 to understand how to solve problems that combine extreme size, high output, and reliability. Lessons that transcend aviation and apply to modern machinery, robotics, and high-performance engines. Historical impact. The Pratt Whitney R-4360 played a key role in post-World War II aviation, powering bombers, transport planes, and commercial aircraft. For example, the B-36 Peacemaker bomber relied on its massive output to carry nuclear payloads over intercontinental distances. Civilian planes like the Douglas DC-7 benefited from the engine's high speed and reliability. It represents the pinnacle of piston engine design before jet engines took over. Pilots and engineers alike were in awe of the Corncob's capabilities. It pushed aircraft design further than ever, enabling higher speeds, heavier payloads, and longer missions. The Corncob is more than a relic. It's a symbol of human ambition, showing how engineers pushed every boundary of mechanical performance to meet the demands of an era. Its ingenuity continues to inspire enthusiasts, historians, and engineers worldwide. Lessons from the Corncob. The R4360 teaches us broader lessons about engineering, ambition, and trade-offs. It shows that achieving extreme performance often requires complexity, precision, and human expertise. You can't just build raw power, you must design for reliability, maintenance, and harmony among components. It also shows that bold ideas sometimes come with challenges. The engine's insane maintenance requirements tested the patience and skill of mechanics, reminding us that innovation often demands dedication and perseverance. Finally, the Corncob exemplifies the balance between ambition and practicality. Engineers created a machine of unparalleled performance, but it came with trade-offs in weight, maintenance, and complexity. The lesson is clear. Pushing boundaries requires not just creativity, but also respect for the limits of both machines and humans. Like, share, and subscribe for more.